In today's video, we shall see something which is very interesting, which is unnoticed by us. Yes, it is the free fall. Anything that falls reaches the earth, never goes up. Have you noticed? Yes. So, here free fall means anything that falls to the earth under the force of gravity is called free fall. And when objects fall to the earth, they all fall with different velocities and at different times. This is only because of the air resistance that makes it to fall on the earth at different times. But imagine that there is no air resistance, or when there is negligible air resistance. What would happen? Yes, the objects all would fall at the same speed and at the same time. Newton noticed all this and said that whenever objects fall towards the earth under the force of attraction by the earth, we say that the object is in free fall, and it is because of the gravitational force of the earth. Objects of different shapes accelerate differently when they fall towards the earth. That is the gravitational force, and the acceleration due to this gravity is said to be the gravity g. Let us see how the value of gravity g came into existence. For free fall, force is the product of the mass and acceleration due to gravity, and so the expression becomes F is equal to mg instead of ma. Also, the force of attraction of the object on the surface of the earth, we have already learnt, is F is equal to g m by d square. Now, the two equations given here can be equated to each other as mg is equal to gmm by d square, where small letter m is the mass of the object in both the cases, and so they can be cancelled, and the remaining is g is equal to capital G into m by d square, which is the expression for the acceleration due to gravity, that is g is equal to gm by d square. Let us see what is the value of g here. Consider the equation g is equal to gm by d square, and let g be the gravitational constant and capital M the mass of the earth, and the distance of the object from the earth is the radius of the earth, that is 6.4 into 10 raised to 6 meter. Now, substituting the value of all the variables given here, we get g is equal to 6.67 into 10 raised to negative 11 into 6 into 10 raised to 24 divided by 6.4 into 10 raised to 6 the whole square. After all the cancellations and reductions, and finally arriving at the answer, we get g is equal to 9.8 meter per second square. And so we take the small letter g, which is gravity, as 9.8 meter per second square. Sometimes for doing the problems, this can be taken as the round value, that is 10 meter per second square. Earth is not a perfect sphere. As the radius of the earth increases from the pole to the equator, similarly g becomes 0 at the equator and increases as it moves towards the poles. At poles it is maximum, and so the g value at poles is 9.8 meter per second square. G is said to be a vector quantity. Acceleration due to gravity, or the acceleration, is a vector quantity. G is positive when acceleration is in the direction of velocity. That means when the object is moving towards the earth, we say G is positive, and when it goes away from the earth, we say that it is negative. G is negative when acceleration is opposite to the direction of velocity. And G is a constant near the earth. Usually we take the value of G usually as 9.8 or 10 meter per second square. The value of G is different for different planets. As you will be learning here again in the topic which is called weight, you will notice that the object when taken to different planets, it weighs differently. And so we say that it is dependent on the gravity of that planet in which the object is placed. And so we say that G is different for different planets. Keeping in mind all these things, you can do problems based on the gravity as well as on the force of attraction between any two objects based on the universal law of gravitation.